Welcome to lesson 8.4, Transforming Quadratic Functions. In this lesson, we're going to learn to modify, or actually look at equations of quadratic functions and predict whether the quadratic functions are getting more narrower or whether they're getting wider, whether the functions are moving up or down, or if they're opening upwards or if they're opening downwards. Now let's graph a few quadratic functions here. I'm going to graph a very basic quadratic function, y equals x squared. And we can see over here, here's a very basic quadratic function, y equals x squared. Now, what if I put a number in front of the x squared? If I said y equals, let's say, 2x squared, what happens? You can see it in blue here, the 2x squared, it's actually getting narrower. Because the parabola y equals 2x squared is getting narrower, it's actually growing faster, see, at the same value. For example, if we look at this graph right here, when at 2, when x is 2 here, the y value is 4. But when x is 2 on the 2x squared graph, the y value would be 8. We could always plug in 2 for x and solve for y. 2 squared is 4, so y is 4. And when you plug in 2 for y equals 2x squared, we will get 8. So this graph is getting, the blue graph here is growing faster. Now what happens if I, instead of using 2, what if I did a 1/2? Because y equals x squared means 1x squared. Let's do y equals 1/2 x squared. Look at the green graph. Now it's getting wider. And it might be easier to show. Let's say it's even small. Let's say 1/4. 1/4. Now it's really wide. See the green, it's really wide. Now let's see, what if I did a y equals negative x squared graph? What would that look like? A negative x squared graph. Now it's opening downwards. Now this is called a reflection in math because it's reflected across this horizontal x-axis. Right now the graph is opening downward, which is called a reflection. Okay. Now, let's go back to the y equals x squared graph, which is the graph in red. What if I did y equals x squared plus 3? Now the graph, instead of having a vertex at 0, 0, it now has a vertex at 0, 3. Whoops, sorry here. The mouse keeps, I have to turn the mouse off because there it is. At 0, 3 here, we can now see, oh, sorry, I can't, it's hard to move this. Let me get this graph here. Okay, 0, 3 right here. We can see the vertex at 0, 3 because we just shifted up 3 units. Now, what if I went over here and I made it plus 6? Y equals x squared plus 6. Now the vertex is at 0, 6. So as I increase the numbers up here, the graph is moving up. What if I did a negative? What if I did x squared minus 3? Now the graph is shifted downwards. Instead of being at a vertex at 0, 0, it's now at 0, minus 3. So let's look at the worksheets now, 8.4 reading strategies. So in the first example, it says f of x equals x squared, g of x equals 4x squared. And look at the f of x, that's one equation, and g of x is the other equation. F of x, we can see it right here. Let me see if I can, here, we're going to do the f of x here, which is right here. I'm going to do that in black. There's the regular x squared equation. And then the g of x, I'll do it in red. See, it's 4, so expect it, as numbers get bigger than 1, they actually get more narrow. See, it's more narrow. Now the next example, y equals x squared, which is f of x. Here's the f of x equation. Again, we can always plot it by just making an xy table. And let's look at the 1/2 x squared, which is wider. The graph is getting wider. Now we're doing a transformation where we're moving the graph upwards. F of x equals x squared. And g of x equals x squared plus 5. So the graph is shifted upwards. Proper terminology is translated up 5 units. And lastly, we have, again, the basic x squared graph right here. And now we have g of x, which says x squared minus 7. So the vertex is going to be shifted down 7 units. Instead of at 0, 0, it's at 0, minus 7. So this is translated down 7 units. Let's look at number 1. For which function which is wider, g of x equals 4x squared, or g of x equals 1/2 x squared? So which makes it wider, the 4 or the 1/2? If we look over here, any number greater than 1 gets narrower. If we look at the first example, so the 4x squared would be more narrow. So which is, but the question is which is wider? Of course, the wider one will be the g of x equation. The fraction here will get wider. How would you be able to tell without looking at it? Well, we look at the coefficients in front of the x squared. The fact that the number is less, the number it's smaller. 1/2 is smaller than 4. So it's going to be wider. Now, why would g of x equals 4x squared, h of x equals negative 4x squared have the same width? Well, the numbers are both 4. The negative sign, so if I were to graph it, it would look like this. This would also be of a width of 4, but the negative sign just tells us it's opening down. But they have the same width. So I would say why it's the same coefficient of 4. The only difference is one is opening up and one is opening down. And a lot of times this value we call is the A value. The A is 4. It's the same value. Now, how would the graphs be different? Well, the h of x graph, the negative 4x squared graph, will opens downward. Downward. Now, order the graphs of the following functions from narrow to widest. Now, it's always a good idea to pause the video and try it on your own, and then we can just check the answer with the video. Or the graphs from the narrowest to the widest. The widest will be the smallest number. Remember, we ignore the negative sign. We just look at the numbers themselves. And the narrowest will have the highest number. So the widest will have the smallest number. The narrowest will have the widest number. Well, the biggest number here is the number 3. The next biggest number would be 2. Again, we ignore the negative sign. The next biggest number would be a 1, which is right here. And of course, the widest would be, oh, I think did we number the narrowest was number 1. I'm sorry. I apologize. The narrowest was 1. So we'll start with the narrowest, which is the biggest number of 3. And then 2. And then 1. Again, we ignore the negative sign. And the widest one would be the last one, which is 1/4 x squared. So if we were to kind of picture it, this would be really narrow with a 3. This would get a little bit wider. This one would be a little bit wider. And this one would be the widest parabola, the widest. Number 4, which has its vertex below the x-axis? So if we had a graph here, which one of these? We have a g of x equation here equals x squared plus 5. Or the g of x, I'm sorry, they should have given it a different letter like h of x or something. But they call it g of x again is equal to x squared minus 7. Which one would be below the x-axis? Here's the x-axis. There's the y-axis. Well, the x squared plus 5 would look something like this. Instead of a vertex at 0, 0, the vertex is at 0, comma 5. If we plugged in 0 for x, we would get y equals 5. Now, the x squared minus 7 would be down here. It's just down. So which vertex has it below it? The answer here, of course, would be the x squared minus 7. That would be the answer for number 4. How would you be able to tell without looking at the graphs? The negative 7 value. I'll just type here, negative 7 means the parabola is shifted down 7 units. When I say shifted, we could also say translated. Our notes proper terminology is translated down 7 units. Now, how many vertical units separate the y-intercepts of x squared plus 5 and x squared minus 7? How far away would those two the vertices would they be from each other? Well, one of them is going to be 5 units above the x-axis, and the other one will be 7 units below. So it would be 12 units. Again, how will we be able to tell? Well, the x squared plus 5 is translated up 5 units. The x squared minus 7 graph is translated down 7 units. So the distance is 12 units between them. Now let's look at section 8 for practice A worksheet. Number 1, order the functions from narrowest to widest. Well, the most narrow function will have the bigger number. In this case, it's f of x because it's 5x squared compared to a 2. 5 is bigger, so that would be more narrow. So from narrow to wide. So it would be f of x, then it would be g of x. Or we could write it as 5x squared and then 2x squared. Okay? Number 2. The narrowest, of course, is always the biggest number, which is right here, the g of x. So I would write, maybe I'll write the whole thing so it's less confusing. This would be the most narrow. The next one, well, what's the next bigger number? Is it 1/2 or is it the number 1? 1 is bigger. So h of x would be more narrow. And the widest one would be f of x. Let me write h of x equals x squared. And f of x equals 1/2 x squared. Number 3. Compare the graph of each function with the graph of f of x equals x squared. So we're comparing each time to this x squared graph. The x squared minus 3. Well, the same number of 1 is in front of both. So the width is the same. Opens up or down. Well, it's a positive x squared. Positive x squared minus 3. This right here is a positive 1. So it opens up. The graph would be opening upwards. Now the vertex is normally at 0, 0. But in this case, if we look at it right here, it's minus 3. That means it's shifted down 3 units. So the vertex is minus 3. So if we had a graph here, 1, 2, 3, normally the graph would have been right here. But we're shifting everything down 3 units. So the parabola would actually be, in this case, here. It's down 3 units. Number 4. 1/5 compared to the number 1. 1/5 x squared compared to 1x squared. Well, 1/5, it's going to be wider. So the width, we could say it's going to be wider, the g of x is wider. It's still positive 1/5, so it's going to open up. Now the vertex, this graph is not shifted up or down. If it were, it would have like a plus a number here or a minus some number here, and there's nothing there. So the vertex is your regular vertex of 0, 0. That's your basic vertex for any parabola, 0, 0. Number 5, 2x squared. Well, the 2 is bigger than 1, so this one will be wider. Excuse me, I should have said that. It's going to be narrower. I apologize. Narrower. It's a positive 2, so it opens up. It's a positive 2x squared. And the vertex here, it is a plus 4, so the graph is shifted up 4 units. Again, a basic graph, y equals x squared, has a vertex at 0. But this graph would be shifted up 4 units. 4 units. Number 6. The width is a 1 value. Even though it's negative, that's okay. It's just a 1. And the original was also 1x squared. So it's going to have the same width, but it's a negative, so it opens down. This parabola is going to open downwards, the negative x squared minus 1. The vertex, see how it's a minus 1 here? It's shifted down 1 unit. So with this graph, normally a y equals x squared looks like this. There's your basic x squared graph. But our graph here is opening downwards and is shifted 1 unit down. So it'll look like this. This would be the g of x here. Shifted down 1 unit, and it's opening down. Number 7. 2 blocks are dropped, one from a height of 400 feet, another from a height of 256 feet. So one is dropped from 400 feet, and the other one's going to be dropped from 256 feet, which is kind of hard, maybe right about there. Now, this is going to be a starting height, and these graphs will generally look something like this. They're going to come down like this, something like that. Now, for all parabolas, if they get for problems that are in free fall or something that's being thrown, this is actually called a free fall. When you throw something or if you drop something, free fall. You can throw something upwards; it's still a free fall problem. The starting height for one of them is 400 feet, and the other one has a starting height of 256 feet. And see here, they're both a negative, which means they're both opening down. The t squared is like an x squared. It's a parabola. It says sketch and compare the graphs. It says tell when each block reaches the ground. Well, we can actually solve for it. When this block, we have two equations here, h of 1 of t and h of 2 of t, or h sub 2 of t. For the h1 of t is minus 16 t squared plus 400. We could solve for t. My question is, what is the height of the block when it reaches the ground? Is it 400 feet high? Is it 350? Is it 300? Okay, now we can solve this graph. Let's see here. We know that when this object, when this block is thrown and it falls to the ground, the height would be 0. So we can set this equation equal to 0, and we can solve for t. So we're going to solve for t here. We have to first subtract 400 from both sides. And we'll get minus 16 t squared is equal to 0 minus 400 is minus 400. Now we're going to keep solving for t. So now we can divide both sides by negative 16. So we'll get t squared is equal to negative 400 divided by 16. We could use a calculator, but I'll just reduce it here. I can go half and half. A negative over a negative is a positive. 200 over 8, which is going to be 100 over 4. And I know 100 divided by 4 is 25. So t squared is 25. Now we take the square root of both sides to solve for t. And t is equal to 5 seconds. So let me graph this first one. At a height of 400, it'll hit the ground at 5 seconds right here. So it's going to be a parabola that opens downwards, and we're starting at 400. Now this is not a straight line. This should be a parabola shape. It's a little hard for me to graph it. To get the actual points, we'd have to make an XY table. But it'll look something like that. Now let's solve for the other equation, minus 16t squared plus 256, and we'll set this equation also equal to 0. So we're going to solve for t squared. We'll first subtract the 256 from both sides. So we have minus 16t squared equals 0 minus 256 is a negative 256. We will now divide both sides by negative 16. Oops, there we get t squared is equal to, now negative 256 divided by negative 16. If we use it on a calculator, we'll get 16. And then of course we have to take the square root of both sides. Square root of t squared is t, and the square root of 16 is 4. This is interesting. An object dropped from just 256 feet high will hit the ground in 4 seconds. Well, let's try to get a little parabola shape here. There we go. It says sketch and compare the graphs. Well, we could say we know that the h1 equation, or the h sub 1 of t, is higher. So sketch and compare. We can just say it's higher. Or you could say it's translated up. Okay, it's higher. Tell when each block hits the ground. Oh, and I'm sorry, we did that already. 5 seconds for the our first equation, and 4 seconds for the second equation. So we know the times already. 5 seconds right here, and at 4 seconds. They're going to have the same shape. Just that one graph is, of course, is just a lot higher than the other graph. Well, that concludes this lesson.